Good day everyone, this is chapter 2, Principle of Hydrostatic, Problem 2, Absolute and Gauge Pressure by 𝐁𝐨𝐫𝐚. Problem 2-45. A bicycle tire is inflated at sea level where the atmospheric pressure is 103.1 kPa absolute and the temperature is 20 degrees Celsius to 450 kPa or kilopascal. Assuming the tire does not expand, what is the absolute pressure and atmospheric pressure in kilopascal on the top of a mountain where the altitude is 6,000 meter, when the gauge pressure within the tire is 487,450 Pascal and the temperature is 10 degrees Celsius. So at the sea level, the given is gauge pressure is equals to 450 kilopascal and the atmospheric pressure is equals to 103.1 kilopascal absolute and the temperature 1 is equals to 20 degrees Celsius and the volume 1 is unknown. So on the top of the mountain, the altitude is equals to 6,000 meter and the gauge pressure is equals to 487,450 Pascal and the temperature 2 is equals to 10 degrees Celsius and also the V2 is unknown. Pressure. Pressure is the force applied perpendicular to the surface of an object per unit area over which that force is distributed. This controls how fluids flow in rivers and hoses. Absolute pressure. An absolute pressure measurements measures the difference from the ideal or absolute vacuum. This is why the measurements is independent of environmental influence such as weather or altitude. The total pressure or absolute pressure is thus the sum of gauge pressure and atmospheric pressure. So the formula is absolute pressure is equals to P gauge plus atmospheric pressure. Gauge pressure. Gauge pressure is the pressure relative to atmospheric pressure. Gauge pressure is positive for pressures above the atmospheric pressure and negative for pressures below it. Local atmospheric pressure. In most cases, this is the pressure caused by the Earth's atmosphere, unless you happen to be on another planet. This pressure is commonly affected by altitude, wind velocity, and temperature. To solve this problem, we must first write the given. Gauge pressure is equals to 450 kilopascal. Atmospheric pressure is equals to 103.1 kilopascal absolute. Temperature 1 is equals to 20 degrees Celsius and the volume 1 is unknown. As we mentioned earlier, we will use the formula absolute pressure is equals to gauge pressure plus atmospheric pressure. At sea level, first we must solve the absolute pressure by adding the gauge pressure and the atmospheric pressure, which is 450 kilopascal plus 103.1 kilopascal absolute, which is the answer is 553.1 kilopascal absolute. And meanwhile, we also need to convert the temperature to its SI units, which is then the 20 degrees Celsius plus 273 constant is equals to 293 Kelvin. Next is to solve for the absolute pressure on the top of the mountain. Since the tire does not expand, V2 is the same as V1. Given that altitude of 6,000 meter and P1 is equals to 553.1 kilopascal absolute and T1 is equals to 293 Kelvin and V1 is unknown. Gauge pressure 2 is equals to 487,450 Pascal, and the T2 equals to 283 Kelvin, and the V2 is also unknown. To convert 10 degrees Celsius plus 273 constants is equals to 283 Kelvin, and for 487,450 Pascal to 487.45 kilopascal. Then we can use the combined gas law formula by the formula of PV over T, in which we will substitute P, absolute pressure, as the total pressure were in 553.1 kilopascal absolute, times V1 over T1, which is 293 Kelvin. But since atmospheric pressure 2 is missing, we will put this as 487.45 kilopascal plus atmospheric pressure 2 times volume 2 over temperature 2, which is 283 Kelvin, which would result to atmospheric pressure of 46.77 kilopascal absolute. Then to get the missing absolute pressure at the top of the mountain, add the atmospheric pressure 46.77 kilopascal absolute plus 487.45 kilopascal equals to 534.22 kilopascal absolute. That's all for this video. Thank you for watching.